So I have the pleasure to introduce you to Andreas Antonopoulos. This is his new book, The Internet of Money. He just told me that it's not for technicians, so maybe it's a good introduction to get into this topic. It's available on Amazon and other e-commerce stores. So he's going to tell us about decentralization and blockchain. So Andreas, the stage is yours.
Good evening, everyone. Hello. Very glad to be in Frankfurt. I'd like to get an idea of the audience a bit first before we get started. I do see a lot of suits, so this is not my usual audience. This is going to be fun. How many people in this room have Bitcoin? Okay, so about 50%. And how many people have not have Bitcoin, but have used Bitcoin once? Okay, great. And how many people would like to have Bitcoin at the end of today? Okay, excellent. Come and see me afterwards. I would be delighted to help you set up a wallet, give you €1 or €2 in Bitcoin, not 1 or 2 Bitcoin. I see you smiling there. No, it's going to be €1 or €2. Just so you can try it, make some transactions, and experience this technology. I want to talk about decentralization today, and what is and what isn't a blockchain. I'll start with a famous quote by Henry Ford, and he said, "If I had asked my customers what they wanted, they would have said faster horses." The essence of disruption is not delivering what people want, but what people actually need. And in this space, what people actually need and what people say they want is often very different. We find a lot of confusion in this new space, the Bitcoin and blockchain space. Bitcoin and blockchain. I don't work in the Bitcoin and blockchain space. I work in Bitcoin. I also work in other open, borderless, public, decentralized blockchains. You know, the ones that actually work. And I don't consider myself a FinTech professional. For the same reason that Henry Ford wouldn't consider going to a horse tech conference, for the same reason that the early internet pioneers would not go to a phone tech conference, because the car was not just a faster horse, and the internet was not just a fancy phone. And Bitcoin is not just a fancy database that can be given a fancy name like blockchain and adopted in a centralized, controlled database fashion by a bank. So, bad news, that doesn't work. And what I want to tell you is why that doesn't work. It's not just a statement of opinion, but it's based on some experience with this area. So, what is a blockchain and what is Bitcoin? How do they differ? What is this idea? You hear a lot of people say blockchain is the technology behind Bitcoin. And that is partly true. Blockchain is one of the technologies behind Bitcoin. It's actually one of 4 essential components that allow Bitcoin to be an open, borderless, neutral, decentralized, censorship-resistant, permissionless system. And that global system, that ability to be an open, borderless technology is what gives it enormous power, because it allows people to innovate without asking for permission. It allows people to build applications that will deliver the trust from the platform of the Bitcoin blockchain. This, of course, also applies to the Ethereum blockchain and the Zcash blockchain and the Monero blockchain and the Dash blockchain, and there's many other open, borderless blockchains. But it doesn't apply to everything that people are calling blockchain. And the reason is that most of these other things lack the essential ingredients to be open, decentralized, permissionless, neutral, and censorship resistant. And essentially they are not. They are a database. A slow, inefficient, controlled, insecure database. Because if you take blockchain and you strip it of all of the other components that make this technology special, you end up with something that is fundamentally insecure and inefficient. So what are the 4 ingredients that allow a blockchain, together with these other ingredients, to create something that is open, borderless, decentralized, neutral, censorship resistant? Something where anyone can participate without asking for permission, where anyone can be part of the consensus algorithm without asking for permission, and anyone can innovate and build new applications without asking for permission. The 4 components are the blockchain database, which is a decentralized, replicated database that can be distributed to multiple points around the world and validated independently by anyone. A consensus algorithm called proof of work. And this consensus algorithm is open for anyone to participate as a contributor to the consensus algorithm and use a common set of validation rules to provide neutral, unbiased validation of transactions without censorship and in a very decentralized manner. In order for the consensus algorithm to work, it requires some additional things. So these things build on each other. The blockchain database gives you a start. It allows you to have a replicated, decentralized, synchronized database of transactions, a ledger. And that can be a basis for trust. But in order for the blockchain itself to be decentralized, the consensus mechanism that controls who can write to it must also be decentralized. Otherwise, if control over the blockchain is centralized, then the blockchain itself is centralized. It is no longer neutral. It is no longer censorship resistant. It cannot be open. It cannot be borderless. It cannot be permissionless. So the consensus algorithm allows you to open the blockchain and make it fully decentralized. And in order for the consensus algorithm itself to be open, you need one more ingredient. You need a game theoretical competition. And this game theoretical competition allows anonymous participants who are part of the system to compete against each other for resources. As they compete, they stand a chance of earning reward. But that reward must be tied directly to the blockchain that they are validated, which brings us to the 3rd very important ingredient. In order to have an open consensus algorithm with competition, you need a native, intrinsic asset which acts as a reward for that competition. It can't be an extrinsic asset. If it is an extrinsic asset, then possession of that asset is determined by other factors, not by whether the validation was correct. It ruins the game theoretical competition. If you can control the asset, if the asset can be removed, if it's not native to the blockchain, then it can't be part of the competition. Because you could win the blockchain competition, the consensus algorithm competition in theory, but because the asset is controlled by another party, you don't get it. Why? Because you validated the wrong transaction, the one someone didn't want you to validate. So censorship can happen, right? So the asset has to be native. It has to be governed by the same rules of consensus that you are competing for, otherwise it doesn't work. So a native asset is the 3rd critical ingredient. A native asset allows the competition in the consensus algorithm to be fully open, fully decentralized. It also allows the participants to be able to operate without fear of coercion or censorship, which then allows them to operate in a way that is neutral. Neutral meaning that they can approve transactions regardless of the source or destination or value, purely based on whether those transactions are valid according to the consensus rules. The only rules that matter are the consensus rules. Because the only rules that matter are the consensus rules, and these rules are universal, the blockchain can be global, it can be borderless. Those rules apply in every country, in every jurisdiction, because there is no exception. Yes, but not here. Or yes, but not to that recipient. Or yes, but not for that pair. So, as you can see, each step of these ingredients increases the level of decentralization openness that you can achieve with the blockchain platform. And then the fourth component, which is equally important, is an extrinsic energy risk or an extrinsic cost. In order to have a game theoretical competition that results in reward, you must have the possibility of failure. You must have risk. Reward without risk doesn't work. Capitalism without risk doesn't work. Markets without risk do not work. In every market, in every competition, in every game theoretical model, you have to have a fine balance between the possibility of reward and the possibility of loss due to risk. In the Bitcoin blockchain, that risk is introduced by the requirement to commit an extrinsic form of energy that is independently verifiable. You must burn CPU cycles. You must hash and burn energy. There is a thermodynamic requirement. This thermodynamic requirement must be committed prior to participation in the competition. It is your entrance ticket. To join the competition, you must present an entrance ticket called proof of work that proves that you have consumed enough energy, that you have put at risk this energy. And that risk that you have positioned with the energy presents a promise to the network. It says, I have committed this energy on the basis that my validation of transaction according to the consensus rules was correct. If you agree with me, reward me. If you disagree with me, I am willing to lose this energy if I failed to follow consensus. And that fourth ingredient is critically important. This is a really subtle point, but a very important point. That fourth ingredient creates one of the most interesting features of this technology, and that is immutability. You'll hear a lot of people tell you that immutability is a result of blockchain technology. That is incorrect. Immutability is not possible on a blockchain. Immutability is the final cumulative step once you have a blockchain with an open participatory consensus algorithm, a native reward asset, and an extrinsic commitment of energy that has to be risked in order to participate. Every time you risk this energy, and this energy is verifiable by everyone, you can look at proof of work, which is a number, and you can say, the only way this number could have been produced, for example on the Bitcoin network, is through the expenditure of 500 megawatts of electricity. It is physically impossible to produce that number any other way than through the expenditure of 500 megawatts of electricity because of the second law of thermodynamics as it applies to information theory. It takes energy to flip a bit. The proof of work shows how many bits you have flipped. In order to have flipped those bits, you had to expend the energy. There is no physics in which that statement is not true. That extrinsic risk of energy is cumulative. Every 10 minutes, 500 megawatts times 10 minutes of energy have been expended in order to change the history of that blockchain. There is only one way. You must expend that energy again. This again is a subtle point. People say, but you can do a 51% attack. What if you have a majority of the hashing power? Even if you have a majority of the hashing power, you do not get to change the past without presenting proof of work. And you have to present proof of work by expending energy. If you have a 51% attack, you have to present twice as much energy. Why? Because you're competing against the other 49% who are also producing proof of energy consumption. So let's say you wanted to overwrite 1 day of transactions on a blockchain such as Bitcoin. 1 day will cost you approximately 1.5 gigawatt hours of energy to produce the first time. If you wanted to attack this network, and you had control of 51% of the hashing power, In order to win an overwrite one day, you would have to expend 3.2 gigawatt hours of electricity, because you would have to expend it faster than the other side is expending 1.5 gigawatt hours of electricity. That's for one day. 2 days, 6 gigawatts. 1 month, do the math. It gets very, very expensive. In fact, after about a week, it's no longer a matter of expensive. It's simply a matter of there isn't the energy. It now becomes physically impossible. In all practical terms, there is not enough energy to overwrite that amount. Today on the blockchain, on the Bitcoin blockchain, if you wanted to overwrite 1 year of Bitcoin with 100% of the hashing power, the maximum rate that it exists today, which is more than it existed at the beginning of the year, it would take you 324 days of computation to rewrite the history of the past year right up to this moment. Right? So 1 year, 365 days of the past would take you 324 days to rewrite. And that is what we call computational immutability. I like to call that thermodynamically guaranteed immutability, because it is backed by energy. So these are the 4 components of the blockchain technology. Of course, when most of the people you hear talking about blockchain, what they're talking about is an Oracle database with some hash signatures, or a slightly slower version of a database, where you just hash link the blocks in the chain. And these systems are not open, they're not borderless, they cannot be, they're not neutral, they cannot be, they're not censorship resistant, and they're not permissionless. And here's why. If you have a blockchain that does not use a native asset, or a competition, or an extrinsic source of energy, then you cannot make the consensus algorithm open. Because the participants in the consensus algorithm, having no other means to be trusted, must be themselves trusted. They must be vetted. Which means that you must give permission to a very specific subset of participants, also known as a consortium. Have you heard of consortium blockchains? Anybody heard of consortium blockchains? Yes. I like a different word for consortium. In the old days, we used to use this term. We used to call that a cartel. Have you heard of that term? A cartel. That's what happens when all the participants in the market are the only ones who oversee the clearing of their own transactions. That's called a cartel. So if you had all of the participants in a blockchain consensus algorithm run by a consortium, what happens then? These people are named, trusted, vetted, these organizations. They have specific keys, signing keys perhaps, that they use to validate transactions. They're not engaging in competition for the native asset. In fact, the game theoretical model that these participants are operating on is extrinsic to the chain. Because there's no reward for validating transaction, and there's no penalty for breaking the consensus rules, then the question is, does this transaction benefit or not benefit my current market positioning in the market that I'm clearing, which could be a stock market, a bond market, or some other market. So this idea of using consortium blockchain to create semi-decentralized clearinghouses that are run by consortiums of financial institutions to replace the centralized clearinghouses is really a dead end, in my opinion. What it does is it removes the one party, the clearinghouse, that is a disinterested third party that only has fiduciary oversight responsibility and is not a market participant and therefore not incented to collude, coerce, front-run, and invalidate transactions, and replaces that participant with a consortium of participants who are all market makers, who are all market participants, for whom the greatest value lies not in the chain, but in gaming the chain in order to take gain from the transactions that are happening in the market itself. And so the consortium is incented to front-run, collude, undermine, cheat. There is no risk. There's no immutability, because if many participants are required, perhaps by court order, there are known participants, you can find them, you can serve them with a court order, and you can say, on September the 12th, you made a transaction which started a chain reaction that ended in the collapse of Deutsche Bank. We would like you to reverse that transaction. We would like you to stop the market, reverse the transaction, roll it back to the golden days before Deutsche Bank collapsed, and let's all pretend it didn't happen. And here's a court order. What do the market participants do? And then the question becomes, how much energy do they need to expend to reverse that blockchain? No energy at all. 1 minute of computation, redo the transactions, boom, history is rewritten. And no third-party participant can ever validate that the history was ever different from this presented. It is completely invisible to outside participants. In a thermodynamically guaranteed blockchain, you can always preserve the alternative history. You can say, look at this. This has 3 gigawatt hours of proof of work. You're seeing something else on the network, but this that has 3 gigawatt hours, look at it. It happened. It must have happened. There is no way this could have been produced other than through spending 3 gigawatt hours of electricity. Someone spent this electricity. They've rewritten the history, but this is the real history, and it carries within it the proof that it is real, that anyone can validate without any comparison against the source of authority. It is self-verifying. It has self-sovereign authority, and this is a unique concept within the blockchain technology. So this is the argument that's happening in the business today. We have this massively disruptive technology. This technology that was started with Bitcoin and has been replicated with a number of open, borderless, transnational, completely decentralized or mostly decentralized systems that are not under the control of anyone, that do not conform to the regulations, that did not ask for regulatory approval. In exactly the tradition of all of the best technology innovations in the world. Do you think Henry Ford asked for regulatory approval to run cars on streets? Do you think that the internet companies that were running cables as early ISPs asked for the permission of the phone companies to create the internet? Do you think that the electricity companies asked for the permission of the whale oil companies to electrify Paris in the 1800s? Permission is not required for innovation. Permission is antithetical to innovation. And Bitcoin and all of the other open blockchains have not asked for permission, do not require regulatory approval. They simply are. They present a fact that has already occurred, the invention of a neutral mathematical system of currency and payments that exists today. It's not a prototype. It's not an experiment. It's not a research paper. It is a fact that exists. A network that has operated for 8 years, beating its heart every 10 minutes without fail. Something that very few networks in the world can say. And not because it hasn't been attacked, but under continuous attack for 8 years. This network is resilient, it is robust, and it gets stronger every day. It presents a pool of liquidity that is small by most standards at only $12 billion. But that is also the basis of a platform and an infrastructure that delivers trust as a service, trust as an application platform for any application you want to write, for which you do not need permission. This is not a research project. This is the most exciting and innovative technology that has happened in computer science in the last 40 years. It rivals the internet itself in its novelty. And it is not FinTech. It is something different altogether. it completely removes the need for FinTech. Because FinTech is the technology provided and produced by financial services companies that operate as hierarchical, centralized institutions, delivering a form of trust that is trust by institution. And Bitcoin offers the world a statement, and that is, we do not need trust by hierarchy, we do not need trust by institution, because we have something new. Trust in math, trust in a network, trust in computation. And that is extremely powerful. Thank you. So thank you so much for welcoming here in Frankfurt. I've really enjoyed the trip. I have to tell you, it is freezing cold here. 1 week ago, I was in Buenos Aires in 38 degrees Celsius weather, wearing a t-shirt. And this morning, I took the train from Cologne to Frankfurt. And as I was passing the scenery, it got whiter and whiter, frostier and more snowy, and I got to Frankfurt, and boy is it cold here. So I appreciate the warm welcome, because in this weather it was definitely needed. I think I have 15 minutes for questions. Is that good? Let's do questions with the audience. Who? Yes, sir.
Yeah, you have a whole book full of talks, so I was wondering if you chose this anti-FinTech talk because you go to Frankfurt to be provocative, or?
You know, if you read my book full of talks, you'll notice that I don't deviate from my message. My message has always been consistent. I've always been a proponent of this technology, and I don't see it as FinTech technology. I don't see blockchain as a database as a valid solution. The book is non-technical in that it is a collection of 11 of my talks from the period of 2013 until the beginning of 2016. And the talks I'm doing now are going in volume 2, so maybe this one will be in there too. Yes?
One more question, it's short. You used to be a proponent for Bitcoin XT, and you have been positive about hard forks, and right now I don't know, I think it's kind of an interesting situation with SegWit having like 25% support right now. You said a few months ago that you thought that it would be adopted within a few months.
Yes.
So that would be like in the beginning of next year.
Yes.
Did anything change, or?
Many things change. Things change all the time in Bitcoin. So to repeat the question for the audience, I used to be a proponent of XT. I wasn't actually a proponent of XT. I was a proponent that we should increase the block size. About 2 years ago, I thought we should increase the block size soon. And I also ran XT along with Core. I've run Classic, I've run Unlimited, I run Ethereum nodes, I've run Zcash nodes. I run all the software. I wasn't a proponent of XT necessarily, but I was a proponent in exploring all different approaches. And what happened over the last 2 years, because I'm no longer a proponent of doing a hard fork at this time. I believe we need to do SegWit first, and I think we should do a hard fork to 2 megabytes at least afterwards. And the reason for that is because my understanding of the technology changed. I received new information, I learned new things, and I adapted my opinion to match the facts. And that means that then I was wrong. And now I may also be wrong. And that's called being human. And I readily admit that I try not to take doctrinaire positions. And I try to adapt and see if I have a different understanding. I'm willing to admit mistake and move on. Right now I think SegWit is probably one of the best tested pieces of technology we've ever seen in Bitcoin, developed by one of the best teams we've ever had in Bitcoin. It offers almost a dozen different improvements on the Bitcoin system, many of them highly critical and required in order to avoid denial of service attacks and to open the door to scaling both on-chain and off-chain. And I think it's a critical prerequisite before we do a hard fork. I am still optimistic that we will see SegWit activate within the first few months of 2017. And I know in week 3, it may not look like that. It's done the little S-curve hump and got stuck at 25%. Does anybody understand what we're talking about here? Okay, this is insider stuff. This is, Bitcoin sausage making. You don't want to see the process. So I'm still optimistic that we will see it activate. I hope we will, because I think it's the best opportunity we have to scale up and to improve Bitcoin. Very good. Anybody else?
You talked
Yes.
a lot about the consensus algorithm.
Uh-huh.
There are also other solutions. So, for example, proof of stake. So, what do you think of proof of stake?
Yes. So the question was that I talk about consensus algorithms, and I mentioned proof of work in my presentation, but there's also others like proof of stake.
Because it would actually
In fact, delegated proof of stake and others, it would avoid the electricity consumption, and yes, it would. I think proof of stake represents a different design trade-off for the particulars of the network, which means that in adopting proof of stake, you are sacrificing something, you are making a trade-off, and in adopting proof of work, you are sacrificing something else. In most engineering practices, there are no perfect solutions, there are only trade-offs between perhaps equally good solutions. So what proof of work does is it costs a lot of energy, but it delivers very robust immutability, thermodynamically guaranteed immutability. Proof of stake costs less energy, no energy perhaps. But to me, it doesn't deliver the same level of robust immutability. And the reason it doesn't deliver the same level of robust immutability is that if the stake you are applying is the native asset, and the consensus rules that you may be willing to violate affect the value or the ownership of that same native asset, you can stake and then, by violating the rules, unstake and rewrite. And you can change the past so that you hadn't staked. So my understanding, and I may be wrong, of course, we haven't yet seen a viable proof-of-stake system in production. I'm very excited to see one. I'm looking forward to seeing Casper, for example, in Ethereum. I've learned through experience that Vitalik Buterin produces some amazing innovation, and not to bet against him. So, if he says proof of stake can be done, it can be done. Now the question is, can it deliver the same level of robust immutability? But the other aspect to that is, maybe you don't need the same level of robust immutability for every chain. In fact, maybe if you have one global chain that provides robust immutability, it can export immutability as a service to other chains. So what I would be really interested in seeing is systems of proof of stake that use periodic checkpointing into the Bitcoin blockchain in order to gain its immutability features, right? So if what you are staking is actually recorded in an immutable, you could in fact stake perhaps sidechain pegged Bitcoins into the Bitcoin chain, which cannot be modified by the consensus rules, and then that stake would be extrinsic. Not only would be extrinsic, but it would also be staked in a highly immutable chain, which would be a very interesting combination. So, I'm not close to these other systems, but we haven't seen any in production. What we do know is proof of work works, and it works at a scale of $12 billion to deliver very robust immutability and security. Let's see. In the back there. Yes?
You said number 4 in your way to decentralization, the cost of electricity of energy. As it is now, the major, how many percent? 90% of Bitcoin is centralized in China.
Yes.
Because of electricity, it can be obtained for almost no charge or no price.
That's one of the reasons, yes.
For under some conditions. Is it somehow reflecting back and changing decentralization point of view? Because
that is a very good point, yes. So the question was, if the fourth ingredient is extrinsic use of energy, what we've seen is the centralization of mining, or the concentration, because it's not really centralization, the concentration of mining in China. Some 80% of the mining happens in China. And you posit that that's because of the availability of energy. I think it's actually 3 different factors that play into the concentration of mining in China, not all of which are stable factors, and this matters. Factor number 1 is cheap energy. Factor number 2 is there is no distribution network for that energy to be redistributed, which means if you have a 20 megawatt factory, power plant in a district in China and they only need 5 megawatts, what do you do with the other 15, right? Sunk cost, you lose it, it goes nowhere, it doesn't get used. So in that case, the electricity is being produced anyway, and putting a mining system next to it ends up subsidizing the decentralization of the energy grid of China, as well as subsidizing alternative forms of energy that produce capacity when it's not needed, solar, wind, etc. So that's an interesting idea. Bitcoin as a way of decentralizing energy sources and acting as a battery. The third reason, and I think the most influential, is the fact that because of the very rapid advancements of ASICs from CPU, GPU, FPGA, ASIC, 28 nanometers all the way down to 16 nanometers, the shelf life of Bitcoin mining equipment traditionally has been less than 3 months up to now. Which means that if you produce it in a silicon fabrication factory in China, you don't have time to export it. It becomes useless the longer it takes to move it. So you want to move it somewhere within a week, install it, and start using it, which means you can't ship it overseas. You can't put it on a container ship. You can't really have distribution. So that created the economics where silicon fabrication to ASIC to mining warehouse to mining pool became a completely vertically integrated industry because of economies of scale. That changes with 16 nanometer. The shelf life of 16 nanometer equipment is now 2 years because there is nothing else after it, right? The next iteration is Moore's Law, so you have to wait 2 years. Now, if the shelf life is 2 years, now we're beginning to see the latest equipment being exported from China and being distributed around the world. So to me, it's the distribution channel that causes concentration, and I think that's changing. It's a complex economic system. Thank you. Good question. 1 or 2 more?
Yes, 2 more questions, I guess.
Okay. Yes?
So you mentioned Zcash a couple of times.
I mentioned Zcash, yes.
And there's a big part in the Bitcoin community claiming that there's a problem with unlinkability and privacy in the Bitcoin network, right? So this is why Zcash was introduced.
Yes.
Where do you see this is going? What's the state of unlinkability in the Bitcoin network in like 5 or 10 years?
So the question was, in many places in the Bitcoin community, one of the issues that's been identified is unlinkability, let's call it anonymity, privacy, but also fungibility of the underlying currency units. And this is a challenge because in its first iteration, Bitcoin is not anonymous, it's weakly pseudonymous, meaning that if you have an address, as long as that address is not associated with you and you use good security practices and use a different address for every transaction, you have some pseudonymity. But if an address is linked to you, then everything you've ever done can be seen. Fungibility and anonymity are problems that are being addressed very actively by several sectors of the cryptocurrency community. And we're seeing a number of attempts to address these issues. There's forward secrecy, which involves protecting the recipient identity. There's the sender secrecy, which involves protecting the identity of the sender. There's the issue of how do you protect the value itself, which Zcash addresses with homomorphic encryption, so that you can't see the value of the transaction, you can't see the sender or the recipient. And there's also mixing technologies that protect the fungibility of coins by creating transactions where multiple participants pay multiple payees, so you can't see who's paying who. All of these technologies are being developed in parallel. There are about 5 different teams working on this. Tumblebit, ring signatures in Monero, the Zcash security layer with zero-knowledge snarks, etc., etc., etc.
There's a problem with compatibility to the Bitcoin, isn't it? Because Like
there is a problem with There is no problem with compatibility with.
Zcash is an altcoin, isn't it?
Zcash is essentially two components. There's a Zcash security layer, or ZSL, and there's a blockchain underneath, which is an alt chain. The blockchain underneath is a direct fork of Bitcoin. The Zcash security layer could be applied exactly as it works, or more or less as it works, onto Bitcoin. We don't have the scale to do it now. That's one of the reasons SegWit would be really useful. SegWit would allow us to implement confidential transactions, which is a homomorphic encryption system for value. It would allow us to implement Lightning Network, which also has an onion routing remixing system. It would allow us to implement Tumblebit and potentially ring signatures and ZK snarks. So all of these technologies in 5 years could be part of a broader ecosystem that's directly connected to Bitcoin. I think all of these things feed on each other. One of the things to realize is that what Bitcoin did is it sparked a revolution in cryptography. We now have the world's largest applied cryptography experiment that has never happened before, the broadest distribution of public key cryptography to consumers in the world, the biggest increase in research in applied cryptography that now has application use cases that can be used immediately in production in the real world. So many exciting things to come. And they can be applied in Bitcoin too.
So, one more question.
One more?
Yeah, I have a very simple question, I hope, is that who would be liable in a system that presents itself as trust in computation? And I would like to elaborate because you mentioned that as the current state is that we trust an institution.
Yes.
Banks, our financial institutions, and in a blockchain or Bitcoin stratosphere, you would have trust in computation and trust in math, which in spirit I couldn't be closer to you. The only issue that I would see, or my concern that I have, is that coming from the past, is that when you trust in something that is non-human, that is basically bits and bytes, you would be liable in case that you need a human touch that, or to simply put this, I do believe that the consensus algorithm does not know any mercy.
The consensus algorithm knows no mercy. Great slogan. So the question was, if these systems are trust in computation and not trust in institution, where does liability lie? How do you achieve recourse? Who do you trust if the system is cold and calculating? You got to realize that these are not simply payment systems. A Bitcoin transaction is not simply a payment. It is a program. It's a script, right? And what you can do is you start with a foundation that offers you a cold calculating, absolutely guaranteed, irreversible commitment, not to make the payment, but to execute the contract, the script, exactly as written. And what that allows you to do is then take that constraint and loosen it. So, I can write a multi-signature script or contract within my transaction. The guarantee the network gives me is that that will be executed exactly as I wrote it, but within that script, I could have a third party act as an intermediary, providing recourse, dispute resolution, mediation, arbitration, escrow, refund, or whatever else I want. Unlike the current system, where the selection of the party of recourse, the source of liability of trust, is intrinsically tied to the payments network. On Bitcoin, through the programmable sense of the transaction, I can select third parties and introduce them voluntarily. So it doesn't mean I can't have counterparty, it means I don't have to have counterparty, but I can introduce counterparties into my transaction. In fact, I operate a company called Third Key Solutions, and one of the things we do is help people design systems that give them reliable counterparty where necessary. For example, systems of succession. If you die and the cold and human calculation says no keys, no money, bye-bye family, right? You have a problem. A judge cannot say, please give all of this Bitcoin to the surviving family of this person, right? So what you do then is you create Bitcoin smart contracts that introduce third parties, such as estate attorneys, trusted intermediaries, lawyers, and they can act in order to provide recourse to the family. But this is good. This cannot be overridden. So once you establish that third party, you are guaranteed that only they can express the wishes and no one else can interfere with that. Also, these systems are non-custodial. So when you place trust in an institution, you do that because they have custody and control of the funds. Bitcoin allows you to have third parties that are non-custodial. The lawyer has one signature out of 3, and with one signature they can do nothing, right? They do not have ownership. They do not have custody. What they can do is they can combine their control with another signature and provide recourse. So you have this market-based approach where you can selectively introduce as many counterparties in as complex contractual relationships you want in a way that opens up opportunities for market-based selection. If I'm trading on PayPal, I only have PayPal as recourse. If I put my money in Deutsche Bank, I only have Deutsche Bank to trust for the liability, and right now I wouldn't put my money in Deutsche Bank. And if I put my money in Bitcoin, I can program who I trust. No one, or someone, or several people with complex contracts. But one thing I know, that contract, once written, will be executed unfailingly and irreversibly by the network. I like that system. And it's voluntary, so if you like it, join me.
So I got one more bit sarcastic question. Is because of this high energy consumption, do you own any shares of energy companies then?
I have never mined Bitcoin, and it often surprises people when I tell them I've been in the space for 5 years. I have never mined Bitcoin, and last time I bought Bitcoin was in 2013. I earned Bitcoin through my labor. And it's one of the nicest places. I don't have any shares in energy companies. Although, based on the fact that I do own a few Bitcoin, I believe that also means that I own the productive means of several Chinese energy firms. They just don't know it.
Okay. So thank you very much, Andreas. Please.